Hello guys, hope everybody will be fine. In this video lecture, I will guide you for steel structure of slab. If you want to build your house and you are not an engineer, so this video is very important for you people. If you want to build your house and you don't know about steel structure design, so watch this video. If you are working on construction site and you don't know about steel structure design, so watch this video. Even if you were a student, so this video is very important for you. Let's get started guys. Steel structure design of slab, but not the proper design. Just I am guiding you what are the some important technical terms in steel structure design. As you can see guys, we have two diagrams. One is by lengthwise, this is a long span and this is a short span. Suppose this span is more than 20 feet and this one is less than 20 feet. Okay, so this is very important. Okay, let me guide you for this. The span is 20 feet and less than 20 feet, and less than you can keep about 12 feet, 14 feet, 16 feet, and span 20 feet, or you can say more than up to, I can say 25 feet. Okay, so I add something more. So this is okay, long section. This is also a long section. Okay guys, this is guys column, this is other column. Okay, and here guys you can see this is slab. This is also slab, column and column. This is the span. This is also span. Now let me guide you for the proper technical terms on this short video. Okay, remember guys, here the span between two columns is 20 feet or more than 20 feet. The span is less than 20 feet. So here we are providing the steel reinforcement inside slab, because the slab we cannot stand without steel reinforcement. Okay, without concrete or also without concrete, because concrete is also the important part of the structure design. Okay, so remember, first of all guys, the first point is that is very important. Use M20 grade concrete. If less than span 20 feet or more than 20 feet, okay, but use M20 grade concrete, which ratio you know very well. Maybe in many videos I have discussed 1:1.5:3. So use this ratio for M20 grade concrete, which is the standard especially for normal residential building, not commercial building. So for commercial building we can increase the grade of concrete. Next guys, we are providing the steel reinforcement. If we have 20 feet or more than 20 feet to up to 25 feet, so we have here L/3 formula, also here L/3. Less than 20 feet we are using L/4 formula, also on this side L/4. So here we have this section. In this section guys, the thickness of this slab should not be less than, remember, not be less than 150 millimeter, or you can say 6 inches. It should not be less than this for normal residential building. The minimum is 5 inches, but normal, the standard length, the depth of or the thickness of the slab should not be less than 6 inches. Here now guys, we are providing steel reinforcement. So L/3 means, for example, we have 21 feet. So for 21 feet, so at the distance of 7 feet here and 7 feet here, okay, so we are providing crank bar like this or extra steel rod. Look here guys, here also from this side guys you can see clearly like this. Okay, so here this span is here now 14 feet from here to this point, and from this point, starting point, to this L/3, this is 7 feet and this is also 7 feet. So now we have 7 plus 7. Okay, so it become 21 feet. Suppose we have 21 feet span, so use the formula L/3, where we are providing extra steel rods or crank bar or bent up bar to resist negative bending moment, because here at the distance of L by 4 or L by 3, we have more chances of cracks. The reason why, because here we have negative bending moment. To resist negative bending moment, here we have positive bending moment, therefore the bars are at the bottom. And here we have negative bending moment also here. So therefore we are providing extra steel rod. So these are the rules regulation of steel structure design. So crank bar or bent up bar is economical compared to extra steel rods, but in many construction, by myself I am using extra steel rods. Extra steel rods, we are providing singly mesh, on the top of that the other mesh which is called doubly mesh. So the singly mesh are placing at the spacing of 12 inches, on the top of that we are providing the other spacing 12 by 12 inches. So at cover or it becomes 6 by 6 inches. On the top of that, especially on the floor beam near its support, left side and right side, as you can see here, because we don't have the continuous beam or continuous slab, so therefore we are providing here, like guys you can see from this center line of this column, in this center line we are providing L by 3 if we have more than 21 feet. If we have less than 21 feet, we are providing L by 4. L by 4 means from this side, this is 21 feet, so we are providing 7 feet extra steel rod. Also here we are providing 7 feet extra steel rod because we have negative bending moment. Negative bending moment, let me guide you for the diagram. So the diagram is negative bending moment, same like this. Look here guys. So here we have positive bending moment, here we have negative bending moment. Therefore we are providing extra steel rods or crank bar or bent up bar, you can say. Next guys, remember here the steel reinforcement. For the steel reinforcement, the spacing should not be more than 6 inches for normal residential building. Let me guide you for this. Guys, you can see this is a slab. So here singly mesh I am placing, you can see. So this spacing should not be more than 6 inches, center to center. And use here 12 millimeter die of steel rod. Not less than this for this. Okay. So, but normally 10 millimeter we are also using, but I am recommending use 12 millimeter die of steel rod with the spacing of 6 inches. But here, guys, you can see, suppose we have a column here, our beam, this side also beam, also we have a beam here. This is also other beam, and this one is the other beam. Okay, so we have a beams here. So here we are providing extra steel rods on the top of main bars and distribution bars on both directions, guys. You can see like this, okay, to resist negative bending moment. It's also depend on two-way and one-way slab. Okay, now guys, we have less than 20 feet, so use here, suppose this is 20 feet, so at the distance of 5 feet here and also 5 feet here, and make crank bar or extra steel rod. So this is 5 feet, this is 5 feet, middle is 10 feet. It become 20 feet. So providing extra steel rod to resist negative bending moment. If you are not using in the future, you will see the cracks near its support, because there we have more chances of cracks. Reason why? We have negative bending moment. At the middle we have positive bending moment. So therefore we don't require to provide extra steel rods. But remember, negative bending moment, don't provide the lapping length. These are some technical important terms in which I am guiding you here. Okay, so guys, here next use 12 millimeter die of steel rod for main bar and distribution bars. Okay, the third one, lapping is not allowed at the distance of L by 3 or L by 4 distance, or L by 4, okay, near its support, as I discussed here. Okay, so the fourth one is, if lapping is required, okay, so provide at the junction between beam and column, not at the distance of L by 4, or after L by 4 you are able to provide at the distance of L by 5, you can say, but don't provide at the middle also, because we have positive bending moment. So if lapping is required, so use here normally you can say 50D or 60D, where D is die of steel rod. Suppose 50 multiplied dia is 12 millimeter, so 600 millimeter. This is the length of lapping. So it should not be less than this. So guys, these are some important information related RCC, slab steel structure design, and the thickness of the slab should not be less than 150 millimeter thickness of slab. Hope this short video can help you. Thanks for watching. See you in next video. Goodbye.